Okay, welcome, ladies and gentlemen. Today is a new chapter. It's chapter 11, and it's called Not Right Triangles. The first chapter was about right triangles, and even when we didn't have a right triangle, all we did was made two right triangles out of it that shared a side. That was kind of the theme, in case you missed that on the test you just took. One note on that. The How many of you have not taken it yet? Raise your hand if you still need to take it. Only one person in here? Two. Okay. All right. You can come in on today after school, or Wednesday Mass would be a very logical time. I'd be happy to hand it to you Wednesday Mass time, or Wednesday after school. So anyway, that's the next three chances when you could take that test. All right. So law of sines. When should I use it? Well, you use it when you have a not right triangle. And why is this any different than last chapter then? Well, basically we have these really cool formulas we're going to share with you. All right, so there's a whole bunch of stuff though about triangles that I think a lot of people don't know, and I want to make sure that you understand this. Most people, if I say, okay, this is a 70-degree angle, and this side's going to be 9, and this side's going to be 11, you'd be like, okay, that's all doable. But no, that triangle does not exist. It can't exist. So what are the rules for triangles anyway? Well, how about this? I know that you know about the 3, 4, 5 triangle. 3, 4, 5. Do you get that in a right triangle, it has to be a squared plus b squared has to equal c squared? Okay. Would you also agree, think about this now, that the longest side in a triangle, and by the way, unless there's the tie, there's always a longest side in a triangle, right? Even if it's not a right triangle, there's one side that's longer than the other ones, unless there's a tie between the two long sides. Okay. Then, what do you know about these two added together? Yes?
They're longer together.
These two are, I like the way you said that. Say that one more time.
They're longer together
They're longer together than
than the
the longest side. Do you get how it wouldn't work if this was a 2, and I know not just because 2 plus 3 equals 5, but also because a squared plus b squared wouldn't equal c squared. But in any triangle, not even just right triangles, these two sides added together cannot equal the same thing as the longest side. That wouldn't work. Okay? Because if those two sides, I'm gonna draw you another one. Let's say they have this base side, and let's say it's 10. Do you get, if you like really squished your triangle down, you might be able to imagine one where this is 2 and this is 9, and that's possible. But do you get that if it was 2 and 8, then that would not make a triangle? Does that make sense to you? Because it wouldn't be able to open up this angle at all. That angle would be like 180 degrees. So that wouldn't actually open up and be a triangle. It would have no space inside it. Okay, so that's one of the rules about drawing a triangle that a lot of people don't know. All right, next thing is, if we're labeling a triangle with A and B and C, you guys are used to a squared plus b squared equals c squared. You get what I'm saying? I shouldn't square that. I should just say, when you set it up like this, a squared plus b squared equals c squared. All right, but what if this wasn't a 90-degree angle? What if this is actually 100 degrees? You get how I actually drew this a little bit wider than 90? Maybe it's 95 degrees, but then a squared plus b squared isn't equal to c squared, but there's actually a superior formula. It's kind of like a squared plus b squared equals c squared, but it's superior because it works for not right triangles. Everybody write this one down. A squared plus b squared, and then leave a lot of room and then say equals c squared. So we'll see that it is pretty much the quadratic formula, but with a little factor built in. Usually there's some kids that know it because this one just gets out, so to speak. A squared plus b squared minus, can anybody say it? Okay, nobody has pre-taken this class, which is it's good. Sometimes you have kids that take it over the summer and then they get like partway through pre-calc and then they like say, that didn't work. I'm going to actually take the pre-calc class. Some people normally I have at least one person knows it. But anyway, minus 2ab cosine of big C. The next thing we have to talk about is that big C is different than little c. If my sides in the past have always been A, B, and C, and you may not have noticed this, but teachers have tried, maybe failed sometimes, to use lowercase letters for sides. You know why? Because uppercase letters are saved for vertices, the corners. All these rules about triangles you didn't know. So what's this side? Capital C. What's the side across from the A over here? That little corner, that vertice. Take a wild guess. Capital A. You are correct. And then what must be across from little b over here? That must be capital B. Okay. So now I want to show you something that's kind of cool. What if this was a right triangle, and this is a 90-degree angle after all, and I told you this formula worked on all triangles? What must cosine of 90 be? 0. The cosine of 90 is 0. Now, you don't know what that means yet. You're thinking cosine adjacent over hypotenuse. That's the ka, in SOHCAHTOA. But we don't do angles. When we do cosine of 90, we do it a different way because you can't see yourself drawing a triangle that has, which one would be the adjacent one if you're going to try to do that with this being a 90-degree angle? There's two adjacent ones. You can't really do it with triangles. But it is true that cosine of 90 is equal to 0. Do you get how that would cancel out this whole piece? And it would just be a squared plus b squared equals c squared. Okay, so all I'm trying to say is this formula works in both right triangles and not right triangles. And it's just that this whole unit is about not right triangles. And if you're only going to teach kids right triangles, why would you teach them this one? Like on the very first day when you learned a squared plus b squared equals c squared, if they tried to throw that at you, you were probably in middle school and you'd have no clue. And you'd have to know what cosine of 90 meant, which you don't even know yet. Okay, so that formula that I just wrote there is called the law of cosines. Now I'm going to write it all the way out. So the next thing that a lot of people don't know is they think that that is a trig function. Cos is not a trig function. Neither is sin. And I know some of you know it, you should say it's sine, but do you know why we say it's sine? It's because the word is S-I-N-E. And cosine is actually co-S-I-N-E. And tangent isn't tan. It's T-A-N-G-E-N-T. I don't know if you've ever processed that, but if you have a three-letter abbreviation like sine, it's just an abbreviation for the actual word, which is sine with an E at the end. Okay? So that's the actual word. So therefore, the law of cosines is actually spelled with an E in it. The law of cosines. I'm never going to test you on that. I just want you to understand that I'm not spelling it wrong. The law of cosines. Okay, so how would you use this law of cosines? Let me give you an example. Imagine for a moment we've got a 100-degree angle. We've got this side's 8. We got this side's 9. Now remember me saying before that there are some triangles that are impossible? Do you think that this one is possible? So far, with the information I've given you? Yes, it is possible. Now what if I said, and this side is 146? Think it's possible now? You get what I'm saying? That's just not, that can't be. Right? All right, so how about this? 8 and 9 and 1 over here. How about that? No, that's not possible. Can't be possible. Now, could I have a side with 8 and 9 and 1? Sure. But this could be 8, this could be 9, and the last side could be 1. But that angle isn't going to be 100. Okay, so back to there are triangles that are possible, that are triangles that are not possible. Do you get if you do a problem and see people tell you, oh, this angle's this and that angle's that and this side is this, and you get no solution, that might mean the triangle doesn't exist? Okay, so you can't just trust that, oh, it's a shape, it must exist. Not all triangles exist. That's kind of a funny way to say it. You can't just pick angles and sides and say, well, as a teacher, you have to be careful because you draw this thing and you go, well, let's let this be 10 and let's this be 12 and let's this be 15. Well, if that's a right triangle, that's not going to work because there's no such thing as a 10, 12, 15 triangle. You know what I mean? So you can't just slap down some sides and some angles and figure, oh, that'll probably work. Okay. So there's two setups you need to be ready for. This one, which was impossible, so I'm going to get that out of there. Now this one, that's possible, as long as we leave that other side open and we can figure out what the other side is. Then, is this a good one for the law of sines or the law of cosines? That's what your next 3 days is going to be all about. It's trying to figure out, should I use the law of sines or the law of cosines? All right. There's no law of tangents. Good question. Although I've heard, if you actually look on the internet, there is one. It's just that it's one of these things that's used only when an elephant steps on your right foot. So you don't use it that often. Okay, so anyways, if I had this one was a great setup for law of cosines. So how do you tell when you want to use the law of cosines? If you have a side angle side situation. Do you remember this from geometry? Side and the angle and the other side? Yeah. They're kind of sassy. Get it? So if you have side angle side, then you want to use law of cosines. Okay. What if you don't have side angle side? What if you have an angle? Would you believe that this could possibly be a 95-degree angle? Do you believe so far that this side could be 10? So far with what I've told you? Yeah, any two pieces of information can usually work. It's all about the third piece of information. If I said, oh yeah, and this one's 106, you'd be like, don't think you can draw one that way, Mr. Server, and you'd be right. Okay, so the next thing you probably didn't know about these triangles is in the past, you've always had three pieces of information. I was kind of lying to you because I would say, all you need is a right triangle and one side and one angle, or two sides. Sounds like only two pieces of information, but when I said right triangle, that meant we had three pieces of information. One right angle and two sides, or one right angle and another angle and a side. So it was always a side and an angle, or two sides, but it was always in a right triangle. So we always had three pieces of information. So again, if you just have this, you don't have enough to know. You cannot solve for the other angles or the other sides. You'll always get three pieces of information. Okay? But as soon as you have that third piece of information, you can solve for everything. You can, just like before, you can figure out every angle and every side. As soon as you give me three pieces of info. All right, this kind, where you have an angle and a side across from it, is a perfect setup for law of sines. All right, I'm going to teach you the law of sines now. Now, remember, I got to give you a third piece of information. It could be anything. You could have an extra side. You could have an extra angle. All right, so I'm going to choose to say, I'm going to pick this angle. And I'm going to say that that angle is going to be, let me think, if that one's 95. Looks like it might be like 40. There, now I got three pieces of info. But if I have an angle and a side across from it, that's a law of sines setup. I wish I could just say that it was like side, angle, side situations. But there's a lot of them that would work. But I can say this is not an ASS. Hmm? So it's not an angle side side, but it is an angle side, AAS. All right, so I'm not going to try to give you tons of combos like that. I can tell you on the other ones, the side angle side, the sassy ones, those are good for the law of cosines. For this, though, it's angle on the side across from it. It's because of how law of sines looks. So everybody copy down this formula. You're going to have to memorize it. We are not going to give you this formula or the other one on the test. These are ones you have to memorize. Ready? Sine of big A. Remember, the capital letters, those are the angles. Those are at the vertices. The little letters, those are the side lengths. Sine of big A, which is an angle, over little a. And now, I bet you've got the pattern. What do you think is coming next? Sine of big B over little b equals sine of big C over little c. That's the law of sines. Now, you pretty much never use all three fractions at once. Do you get all we really need is like one combo like this where you know 3 out of the 4 pieces? Okay. Now, remember me saying you'd have to have one angle and one side across from it to use the law of sines? Think about that. If I have an angle and a side across from it, then that's like this. I have this angle and I have the side across from it. Do you get how that's perfect? Because then all I need is one other thing and I got a nice proportion. Whereas if my 3 pieces of info that I got were 3 sides, for example, if all I had was 3 sides, then do you get I could put like a 5, a 7, and a 9 here, but I could not ever solve it? See how the 3 pieces of info isn't enough unless you've got an angle on the side across from it. Because do you get, if I'm going to give you 2 pieces of info and it's 2 sides, then the last thing has to be an angle. All right? So 2 sides, and one of them has to have an angle across from it. So let's say I said this was 60 or something. Then you could solve it. You could solve this part. Okay, so that's a perfect setup for law of sines, and let's actually use it to solve this question. And I think you're going to want a calculator unless anybody has sine of 40 degrees memorized. I'm going to pause for a second while people borrow calculators and such. Okay. Now, it's kind of important for me to tell you what I want. So, tell me what you want, what you really, really want, Mr. Server. I want this side over here. But what's its letter? Let's talk about letters again and what can be what. All right, I have a good habit for you to develop on which should be which letter. First of all, it could come with pre-lettered Q, R, and S, and you would reject those letters and replace them with your own. Why? Because your formula has A, B, and C in it. Do you get what I'm saying? You're going to have to re-letter it. So no matter what letters it comes with, you get to re-letter it. So then, which should you pick for which? Well, if they were right triangles, I think you know this, on a right triangle, you've always picked C as the longest side, right? Don't do that. But C is the key, again, but it's not always the longest side. C is the key angle. Big C is the key angle. That's what you got to remember. All right, so what's the key angle? Well, in this case, I have 2 angles. But which one's the key angle, the 95 or the 40? The 95 because it's got the side across from it. So the key angle should be C. So everybody please label this as a C. And if that's capital C, then do you get the one across from it as little c? I'm going to put it there, but I'm making it really small. Okay, there's a C. All right. Now for A and B, do you remember on right triangles, we really didn't care. If you weren't the hypotenuse, we didn't care which leg was which. Now, if you knew that, but it's true. The hypotenuse is a big deal. Which one is C? But the other two, the A and B, can be interchanged. Doesn't matter. Same thing here. A and B, they can be anywhere. That could be A, that can be B, or you could reverse that. We don't care. You'll get the same answer either way. But remember, you get to name the triangle. So there, I've named it this way. I'd recommend you do it the same as I am so you can follow your notes. But what does that make this little side right here? Little a. Very good. Okay, so if I'm going to find little a, then set up a proportion. You pop the numbers into the law of sines. And this is the easy one. What was the key angle again? The 95. So that's C. So that's here. So this is sine of 95. And then what's little c? 10. And I want to find A. Do you get I can just completely skip over the middle part because those two will still be equal to each other? You know what I mean? This still equals that. They don't need the thing in the middle to be equal to each other. It's called the transitive property of addition. It's kind of like it transfers from this to this and that to that. So if I have the same amount of money as John and John has the same amount of money as Carrie, I have the same amount of money as Carrie. Let's skip right over John. All right, so back to equals, and then I'm going to do this part. Sine of big A over little a, but I must know 3 out of the 4 things, because if you try to solve that, you have only one equation and 2 variables. You can't solve it. I must know one of those. What do I know? Dang, I don't know either one of those. But can't I figure out one of those? See how I don't know this angle, but then I kind of know that angle? Because you can figure it out so quick. Because they have to add up to 180, and these two together make 135, so then what are we talking about? 45. Double checking this. 95, 180. Yes, excellent. Okay. So since that's now I know what angle A is, I can put a 45 here, and then if you know how to use your calculator, you should be able to solve this puppy. Now I know some of you are maybe lost. All I got to do is type in sine 45, and you get a decimal for this. Please tell me, what's sine 45? Point something. 707? And A, I don't know, equals sine 95. I can do it. I got a calculator. .996 over 10. Ooh, I can save a step. You know why? Because do you get when you divide by 10, you just move the decimal? But just don't mess this up. When I divide by 10, do I make my answer bigger or smaller? Smaller. So I'm going to go .0996. See what I did there? Divided by 10? All right. So now, if you haven't figured this out yet, you remember that one where these two can switch places? If you want, you can multiply both sides by A, and then divide both sides by .0996, but I'm going to just flip-flop those two and say .707 over .0996 is equal to A. And if I can divide, I've got it. Going to pause for a second here. Okay, so that would round to about 7.1. So what do? We figured out that which side was 7.1? Little a, that's this guy, so that's about 7.1. I am rounding, but okay. That's law of sines. That's the main one we're going to use today. But I really want you to get good at figuring out whether to use law of sines or law of cosines. So even if we don't use the law of cosines, I want you to be able to see which problems would work better for it. So this one, having all the angles. Think about this for a second. Does that tell you all the sides? Having all the angles, can you know for sure what the sides have to be? You can know what the ratios are, but you could not know how long the sides are. You could know the ratios. Like, if I made this angle twice as big as this angle, then I could say, oh, it's 30, 60, 90 triangle. I know the sides. You see what I'm saying? I know the side ratios, but I wouldn't know exactly how long are the sides. All right, so if you told me all three angles, it doesn't really help me very much. But if I told you all three sides, I said this was 3, and this was 4, and this was 5, you'd probably be like, oh, I know that one. This is we've got a right angle in it because it's a 3, 4, 5 triangle, and I know one of the angles right away. Would you be able to figure out the other one? Sure you would. Okay, but do you get that's a right triangle? What's the title of this unit? Not right triangles. Okay, so I'm not going to use that one. So I'm going to use the 3, 4, 4.5 triangle because that's definitely not a right triangle. Could you figure out the angles in it? Yes, you can. And now I want you to think about what I've told you about law of sines and the law of cosines. Which one of them can you rule out because it couldn't work? Law of sines, because you don't have an angle on the side across from it. So the law of sines is out, and that gives you the law of cosines. Now, law of cosines, that's the better one, because here, so I can make a tie to stuff you understand. I know you understand quadratics, and you know the quadratic formula, right? And what's the good thing about the quadratic formula? It always works. It can even find the answers when they're negative under the square root, so you can even find imaginary answers. The quadratic formula is the best because it always works. Try to graph this parabola and tell me what its solutions are. You can't by graphing, but you can with the quadratic formula. It always works. Same thing, law of cosines always works. If you can solve it, the law of cosines can do it. So it's the better formula, but it's also not as fun to use because it's got quadratic formula's got 16 parts. Law of cosines, let's count them. So it's A, and then what's the next thing? Squared, that's 2. That's 3. 4, 5. 6. 7. 8. 9. 10, 11, 12, 13, 14. It's got 14 parts. If you forget any of the parts, it doesn't work. You get how that's not as fun to use? Law of sines is not going to... In fact, you're only going to use 4 parts of the law of sines. Okay, you could argue if sine and A are 2 separate parts that it's maybe 6 parts. But it's certainly using 14. Okay, so do you want to use law of cosines? No, it's your last resort. You only use it if you have to. This one would be a law of cosines question because I can't use the law of sines. Law of sines is the easier one. It's just more fun to use and it's easier to remember. Okay, so there's not a song, but I would love it if you would make one. So let's say I had 5 here, and this was a 45. Could you, well, wait, it sort of looks like it's a right angle, but it's not. First of all, do you have enough information? No. How much info do you need? 3 parts. You need 3 things. 3 angles, even that doesn't really work. It gives you the ratios of the sides, but you need at least 1 more angle and 1 more side. 1 more angle or 1 more side. Okay, so let's say I decided to give you that. Danger. Just so you know, it's possible that I just set up a triangle that doesn't exist. Do you get what I'm saying? Remember, not all of these exist. If I just slap sides on here and angles, sometimes you're making a triangle that can't exist in the real world. So I'm hoping you're learning way more than you ever were aware of about right triangles and how you label their sides. All right, but in this case, I'll assume for a moment I didn't set it up wrong. Then, first of all, I did set it up wrong. But if this was possible, the reason I know it's not possible is because this is 5, then if this is a 45, well, actually, maybe it is possible. But at least you should be aware it's not certain that it's possible. Okay. Well, let's imagine it's possible. I got a side and the angle across from it. Which law do I want to use? Law of sines. What if you go through the law of sines and you get an answer and it says error, domain error? You just set up a triangle that wasn't possible. Okay, so I'm warning you on your homework for tonight, there's going to be some where they're going to give you this like scenario, and you're going to put it in and you're going to be like, doesn't work. It's because it's not possible. Okay? So be aware. In the past, you understand, we've already had answers before that weren't possible. And you've heard of like the extraneous answers you think work, and then it turns out they don't. So you know that there's such a thing as no solution. Well, it is even true on shapes. There's shapes that aren't possible because of how long their sides and angles can't be in certain combos. All right, so let's say we were going to use the law of sines. I'm going to annoy you on purpose. Mr. Server, you just did the formula the other way a second ago. But do you get that you can flip them over? Think about it. As long as you flip the left and the right side, it's legal. So why would I ever do that? Do you remember that you want the variable on top? Because then you just have to multiply both sides by its denominator. So trust me on this one. Sometimes it's better to do your law of sines upside down. Because why? Because what if we want to solve for a side? Well, then it'd be better if it was on top. In this case, it wouldn't be better to have it this way. But I just want you to know it's possible to write it either way. I wouldn't mark it wrong for you if you wrote it with a lowercase b where the uppercase is supposed to be, but you will get very confused on the drawings if you get those off. The uppercase ones are the corners. Those are the vertices. So you should have, these should always be capital letters, and these should always be lowercase letters. Okay, last thing on the lettering thing. Do you get A, B, and C are the standard I've used the entire time. But it's also possible to use the Greek A, B, and C. And the Greek A looks like pretty much like a regular A. Would you agree that sort of looks like a little a? Okay, the Greek B sort of looks like a B. It's got a long tail. Okay, can even complete that more, a little more. There we go. And the Greek C, though, doesn't look at all. No, I don't know. You think that looks like a C. All right, so if you get confused, A and B, alpha and beta look normal. The weird letter that you can't recognize, it's a C in the drawings that we have over the next couple days. Alpha, you're going to go, oh yeah, that's the A. Beta, you're going to go, oh yeah, that's the B. But the weird one, the C, I didn't even draw it right up there. I should do a better job. But you're going to see the one weird letter that you can't recognize. It's a C. Yes. Good question. Really, it doesn't matter. You can solve it either way. But for this triangle, I would use this. Why? Because I'm trying to right now solve for an angle. Do you get I only have one angle? And so that means out of these four parts, I'm going to know one of these two. I'm either going to know A or I'm going to know B. And so the thing I'm going to have as a variable would be the angle. So therefore, I'd want this. Because see, I have two sides. The 5 and the 7, they're going to go like here and here. So you want your variables on top. But it can work the other way. It's just like this. If I had this, you'd be like, oh, I wish the A would have been on top. It'd be a lot easier. Why? Flip them. Well, it's easier because if the A had been on top, I can just times by 2 on both sides, and I'm done. See what I mean? So it's just nice to have the variable on top. It's not required. You can always cross multiply. It'll just take you a whole extra step, which is a bit of a pain, and trying to save you as much pain as possible. Okay, so let's actually finish this puppy. So if I put the 5 here and the 7 here, then this angle here is across from the 5, and this angle is going to be the 45, and so I'm going to put it here. And this would totally work. And it wouldn't be wrong. But if I was picking letters, I really, just am warning you, because it only really matters in the law of cosines, but it would be smarter for me to have picked this to be capital C. Remember that the C is the important angle? But do you get if I to put this into the C and the other little c, it's going to end up being the same exact thing? It's going to work either way. Okay. So just trying to tell you, generally speaking, pick big C to be the angle that they have focused on. They only focus on one angle. They have to give you an angle. Let it be C. So then I should have really written sine C over little c, but as soon as I replace them with a 45 and a 5, it doesn't matter anymore. All right, 12 minutes left. I have taught you 2 days worth of trig, so if that felt a little intense, it's okay, because I just taught you law of sines and law of cosines. And that means tomorrow can be just like a review day, so yay. So if you're feeling stressed that this was a lot, it was. But I also taught you everything about right triangles as you didn't know before, and all about how to name them, and all about where the C has to be, and anyway. So that was a lot. Last thing, you're going to see this formula come up, and it's the area of a triangle. The area of a not right triangle is 1/2 AB sine of big C. I just wanted to say it once to try to get it in your head. And law of cosines is the only one that's got cosine in it. Whenever you have another formula, as far as I know for our entire course, all the other formulas that we have use sine, if they're a formula. So this one's an example, or the law of sines uses sine, of course. So you're going to use sine almost always. Law of cosines is like the one time you use cosine in a formula. I'll give you another blast from the past that you know, and it's the chord formula. This is one that can be handy on the ACT. Not saying it comes up a lot, but it does come up. But, do you remember what a chord is? That straight line that goes from 2 spots on a circle like that, that straight line, that's a chord. The curvy part, that's called an arc. But the straight part, that's called a chord. And the chord formula is 2r. And what did I say was the formula that you, or the function that you pretty much always use? Sine. Sine of 1/2 theta is the formula for the chord length. Chord length is 2r sine of 1/2 theta. That got messy in there. That's a 1/2. So what is my point? You're going to use sine a lot. You're only going to use cosine once, and it's in the law of cosines. Okay, let's get started on homework. The 12-minute warning went off, and I want to show you where the homework is. And I also want to get you your test back. So give me just a second here. I'm going to pause. Okay, so this is the first problem of the homework. And we are doing this one. And you might be like, but there's no triangle, Mr. Server. You're right. You have to draw the triangle. And I'm warning you, if you draw it wrong, you can end up getting it wrong. And there are impossible scenarios. This is one of them. There is no way to draw this triangle right. So before you agonize and think, I didn't learn anything today, I can't even do the first problem, it's because the first problem is not possible. And one of the things they're trying to teach you is that there are triangles that don't exist. Okay? So I'm not saying you shouldn't do it. You should do it. And you should see that when you set it up and you put it in the formula that it says no solution. You should see that. Remember, the point isn't like what's the answer, because you can always look at the key to find the answers out. The point is like to experience these problems, see if you could do it. And when you do it all right and it says error, then something's wrong. There's no solution. Okay, so this one, number 6, works. There's a bunch of them that do work. How do you draw it? Well, I can tell you what a 117-degree angle looks like. I can just make it up and say that's 117. This is alpha. That's an A. That's a little a. That's a B, a little b. Okay, and the one that you won't recognize, like you should recognize, that was an A. But the one that you totally don't recognize, that's going to be a C. If everything looks like that, that's a B. It's a beta. Okay, anyway, I want you to do 5 and 6 and 9. And since this one says extra practice, let's cross it off. for the irony that right on top of it it says required to, but that's okay. It's also extra practice. So skipping it, I do the fireplace question because, oh my gosh, those problems again? Yes, bearing problems don't go away. So if you had difficulty with the bearing problem, you should revisit it, maybe come in and do the corrections on it, because bearing's on the next test too. Maybe by the time we take it on 2 tests, you'll have it down. I'd say 3/4 of you had it down, but there's another 1/4 of you that are still confused on the bearings. All right, so do up to the fireplace and including the fireplace problem, if that's it. And that's your homework for tonight. And stay caught up. That's all I have for the video for